Support for your public radio station comes from our members and from City Magazine, covering arts and culture in the greater Rochester community since 1971. On the web daily and in print monthly. More at roccitymag.com. City, arts, music, culture.
From WXXI News, this is Connections. I'm Evan Dawson. Our connection this hour was made with these headlines. Astronomers watching city-killer asteroid to determine chance of striking Earth in 2032. And the odds of a city-killer asteroid impact in 2032 keep rising. Should we be worried? And chilling video shows city-killer asteroid more powerful than 500 atomic bombs hitting the Earth in 2032. And put us out of our misery, please, space. All right, that last one was not a real headline. But they're not very optimistic headlines, I have to say. Those were from just the last 3 weeks or so. Now the situation looks a lot different. The probability of the near-Earth object striking the Earth has decreased from, 3%. Now it's down to like less than 1%. Scientists saying it's going to be close to zero. Buzzkill. But according to an expert who spoke with NPR, the chances are still low. They're not quite zero. We're going to discuss what we know about this. And the pattern that scientists are predicting is that there's going to be things that we're very interested in that are in the sky. And we're going to be wondering, and we're going to be seeing more of them if we're funding it, if we're looking for it. So while it's good news we don't have to worry about a major destructive space event, there are still plenty of questions to answer. Why was the asteroid classified as a city killer? How often do we see these things in range? And if the asteroid were a cause for concern, what could be done to stop it? It sounds like a science fiction movie, of course, but a month ago, those questions weren't just hypothetical. Let's get wonky this hour, and our guest is one of our favorite regular guests, astrophysicist and science writer, Dr. Brian Koberlein is back with us. Welcome. Thank you for being here.
Thank you very much. It's good to be back.
For like a few days there, I was like, we got a 1% chance. Everybody's kind of freaking out. And then they're like, next week, we're going to reevaluate the odds. And this is like a month ago. And they're like, oh, now it's up to like 3%
Yes.
for a few days. And I was like, wow, this thing's really coming. Now they think it's what, down close to zero, but not zero?
Essentially zero, and they expect it to go to zero.
Don't do that. Like, don't ruin this for me already.
This one actually is a great example of what we need to get used to.
No, that's interesting. Used to as in there will be more of these
There's
things?
going to be more of these. There's going to be a lot more of these. Basically where this was we found this in late 2024, so December 2024, and it was coming towards a close approach in 28, and then swinging around and coming back to possibly hit us in 32. And so we just found this thing. We just look at the odds, and they're a few percent, or they're 1%. And then as it continues to move in our direction, that rises. So it raises to up to, I think it was 3.2%.
Yeah, that was
at the highest.
I mean, that's pretty high, right?
That's enough to go, okay.
Yeah.
Let's start making plans. And they actually did start having meetings about what would we do to possibly deflect it and so on and so forth.
You mean they started having meetings? They haven't been having those meetings?
Well, they've had general meetings for a while.
I want them to keep having those meetings.
They do plan on having those meetings
good.
but this specific thing, this was a specific topic of not just how in general would we deflect an asteroid or what would we do, but what would we do in this specific case.
Gotcha.
So it did temporarily raise high enough for us to, start thinking about what we would do.
But isn't it possible that we're just going to doge away all of that funding for
It's possible.
the what to do in the case of a space rock?
That's the thing, is that right now, I mean, if you look at discovered in late 2024, December of 2024, so really 2025, and hitting us in 2032, that's 7 years. And that would be 7 years to plan a mission, build a mission, launch a mission, get there, deflect it, and hope we miss. That's a short time range in the term of how you would do this type of project. And that's common right now. We generally don't find these decades in advance. We generally find them, Years.
When
in
they're pretty
advance.
close.
When they're pretty close.
So that's going to be part of what I want to talk about. So what we're going to talk about with the astrophysicists this hour is how we know this stuff to begin with. The science is amazing that we can even do this. I find that's incredible. And we're going to talk about how we do it. I am curious to know if we invest more in this kind of research, will we eventually start to find them farther out? We'll talk about that. Or is it always going to be they're pretty close, relatively speaking. What these things are made of. We talk about a city killer, how big that is. How does that compare? Everybody's thinking about the dinosaurs, about how that compares, in terms of size. So we'll talk about all that stuff. And we will talk about with Brian what happens if you stop funding things that a lot of people might assume are kind of tangential, not that important. So there's a lot to cover here. So let's start with this particular, it's an asteroid, right?
It's an asteroid.
It means it's made of what?
Rock, maybe some ice,
Okay.
mostly rock.
Okay. That's not the same as a comet?
No, a comet is mostly ice, some rock.
Okay. Mostly rock, some ice. And we find out, as you say, at the end of 2024, this thing exists. And it's going to kind of do this flyby in 28 and may come back around and come toward us. First question I had was, does our existence at all, does it attract objects? Like, would it just be normally going this way, but because we're here, it goes, ooh, boom. And
Yeah, so
I
there
just
is,
did a
there is a
visual thing, and
gravitational
we
dance.
do have a YouTube channel for all the visual.
There is a
watching.
gravitational
It's a
there
great
is
radio.
a gravitational dance, and one of the things that raises the uncertainty is that if you have a close flyby of Earth 1 year, that could, depending on where that path exactly is, could change the trajectory of where it comes the next time.
In a good or a bad way?
Well, that depends.
Okay.
It depends on where it comes in. But whenever you have an asteroid that's a small mass that flies close to a planet like Earth, they both pull each other, but the asteroid gets deflected more. And because of the interaction of their orbits and the gravitational pull between them, you can shift the trajectory. We do this all the time with spacecraft. If you want to launch spacecraft into deep space, rather than just using rocket fuel and thrusting it way out there, you can make a swing by Earth, swing by Jupiter, and get it out into deep space a lot more efficiently.
Slingshot it that way?
The slingshot effect, yeah.
That's
or
what
the
they made.
flyby effect.
Yeah,
as
flyby.
sometimes
Okay.
it's called. Yeah.
Okay. How, to begin with, do we find these things? How did we know about this one?
So this one was found by a telescope that looks at kind of just scans the sky at various patches at the time. And when you find objects, when you go back and look at that same patch of sky, if it's moved, you now know that this is an object that's orbiting the sun. It's not a distant object. And so then if you take multiple images.
Successive? There we
yes.
are.
I don't know why. But multiple images of it, you can then calculate where it is at different times and use that to determine what the orbit is.
I mean, it's remarkable technology, and I assume we're only getting better at it.
We are getting better at it, yeah.
So, as you say, when it comes to these kinds of objects that could strike us, we have to get accustomed to the idea that when we find them, they're not going to be 500 years away, that they're likely to be, in a lifetime or less, or a decade or less.
Right.
Will we get better at finding them farther away or no?
Yes, I think we will. There are, right now, a lot of telescopes have a limited field of view, basically how wide of a patch of sky you can look at any given time. And so generally, there's always been this thing of the higher the resolution, the more detail you want, the smaller the area of sky that you can look at. So you can look at a really detailed object in a very tiny patch of sky, or you can look at a large patch of sky kind of blurry. And so for things like asteroids, this has made it extremely difficult to try and find them because you have to look at a patch, look at another patch, look at another patch, and be able to see, basically map out this area to find them. We are moving now to what are a different type of telescopes, which are sky survey telescopes. So for example, the Vera Rubin telescope in Chile, it is an 8-meter mirror. But rather than an 8-meter mirror that's focused on a small patch of sky, it's able to take a high-resolution image across a wide patch of sky. So what Rubin's going to do is scan the sky every night and basically cover its entire observable sky every few days. And we're going to have images, and asteroids are going to be in those images every few days. And so we're going to find a ton more of these.
This is why I think we might be living in a simulation. This technology is
We live in a
so
world with clever people.
clever people. It's not a simulation. It's just people smarter than you, Evan.
That's
This
right.
Is very straightforward. You've been to Chile at this particular
have.
array.
Yes.
It's amazing. I mean, you told us some great stories about that experience. It's, I was going to use the word spiritual. It's got to be an amazing experience, though.
It's I would say numinal. It's a very numinous experience. It's a dark sky that most people don't experience. And it's so remote and so dark. I would say when the darkest part of the sky there I was at was so dark that the Milky Way cast shadows. I was looking down at the ground going, what is that? Oh, wait, no, that's a shadow. There's nothing up in the sky.
It's
It's
amazing.
just the Milky Way, and you get this kind of blurry, patchy
Amazing.
shadow.
Yeah, it's amazing. And so this tech is getting better. I keep wanting to jump ahead in the conversation to, like, are we going to keep funding it? Like, what happens if we don't fund it? We'll get there coming up here. I also want to talk about scale, though. I want to understand what we know about this particular. So again, the asteroid that's coming back around 2032, Brian was telling us the chances now are close to zero. You think that they will likely go to zero.
They almost always do.
Okay, that's, yeah.
They always have so far.
Fortunately. Well, not always. Talk to the dinosaurs, right?
Well, the ones that we found, I mean, the
ones,
was,
since we've been good enough to find them.
since we've been good enough to find them, they have all gone to zero.
Yeah. And that's a lot, right? I mean, there's a lot that
That's-
we probably don't report on.
Yes.
Smaller objects, things like that.
Well, the smaller objects are larger objects where the odds are so low. The one that people would talk about was Apophis. It was this fairly large, kind of not quite dinosaur killer, but a large asteroid. And
Apophis?
Apophis.
When was that?
It was, oh golly, when they first.
Like in the last generation?
Yeah, about the past decade, it was, oh, well, this has some chance of hitting us. And then as we tracked its orbit more, it's now been delisted. It's considered not a risk at all.
But it was the size of the dinosaur killer?
Not quite. It was large, though. It's when something's large enough to be named, it's probably something you want to worry about. If it's
Good rule
like
of thumb.
172-36-24, it's like that's
Yeah.
probably the size of a
Nothing.
Prius, But if it's named after some member of mythology, you probably go, they took the time to name it.
It's probably something to be worried about. So when it comes to the 2032,
Mhm.
they called it a city killer.
Right.
How big are we talking here?
Roughly the size of a small bus.
I mean, that's still not that large.
It's not that large, but it's not necessarily. I mean, it has to do with its mass, but it has to do with its speed relative to us too.
So am I wrong to hope that if something like that ever comes into our atmosphere that it burns up before impact?
So this is we've had things that are not quite that big. So Chelyabinsk, I think in 2014 in Russia, what it did is it came from the sun side. So we didn't even see it coming, because if any asteroid swings at Earth from the sunward side, it's very difficult to detect right now.
This is not giving confidence here.
So this one just happened to come in fast and shallow. So it hit the atmosphere and it fragmented before it hit the ground in one solid piece.
2014 Russia.
There was 2014 Russia, and there were still fragments that hit the ground.
But didn't it cause windows to blow out?
It did.
And all kinds of.
The airburst was enough to still cause a massive amount of property damage, but it didn't impact a city straight down in one solid chunk where all of that energy would be released at once.
Okay, and
So-
and how big was that one? When it was coming in.
I want to say it was about 20 feet across, something like that.
Okay, so a little bigger than the bus.
A little bigger. Yeah, around the same size. I
Around-
mean,
okay.
if it would have hit straight down over a major metropolitan area, it would have caused significant death and damage.
I mean, like a nuclear explosion.
Basically, yeah.
Yeah.
It-
So in this case, the bus size one from 2032, the initial idea was that if it was going to hit the United States, it looked like it was going to hit I think in the northern part of the southern hemisphere, mostly likely in water, or no?
Yeah, most likely in water.
Okay. I
Yeah.
mean, we're still mostly water, so it's still
Yeah.
it's
The
gonna.
odds are always likely that it's going to hit the ocean.
And could an ocean impact cause all kinds of devastation? Tsunami, things like that?
An ocean impact could cause something like a tsunami, and if we weren't prepared for it, that can cause massive amounts of loss of life and damage.
Okay. Now that we know that this thing is probably not going to hit us, the 2032, is it something we still are we going to keep observing it? Can we still see it right now? I mean, what's the plan with this thing?
So I think it's moved behind the sun right now, but it will pass by Earth. We'll get a good view of it, and then it'll pass by Earth in 2032, and we'll get another good view of it.
Aren't you implying though, like with the Chelyabinsk one in 2014, that there's a whole group of them that could be coming from behind the sun that we're not even seeing?
Well, generally they would go from the outer solar system past us and then around the sun and then back. And so if we don't catch it when it's coming inward, we probably won't catch it when it's coming outward. This is actually one of the things that we look at in terms of how do we try to find these things. One of the projects is to focus on those inward coming asteroids. If you want to make a serious look of these things, you have to look inward as well as outward. Right now, most of the things we find are outward.
How big was the one that killed the dinosaurs?
You're going to ask me that, and I'm going to forget. It was like a mile across or something.
I mean,
it was big.
I mean, so when we're talking, a city killer is a school bus size.
Yeah.
A mile across.
Yeah.
I mean, that's not a planet killer, but doesn't that kind of a planet killer, right?
It made a layer of geological record across the entire planet.
Okay, so
So you can see the line.
I'm surprised anything lived after that.
Yeah.
Pretty remarkable resilience of life there.
Life finds a way, they say.
Somebody once said that.
Yeah. But,
Okay.
usually trying to create massive extinction of everything would be very difficult. I mean, you'd need something absolutely huge.
Like if you gave AI the nuclear codes and everything.
Maybe, but even the full scale launch of that, there'd probably be life that still survives. I mean, there have been many times in which we've had mass extinctions in the history of life on Earth, including almost freezing over as a snowball.
So your point is life would probably survive.
Yeah.
You wouldn't be going to like Starbucks and enjoying yourself.
No. We're fragile on that scale.
Yeah.
There's always, I mean, look at how many cockroaches you find in an apartment. That they're more resilient than we are.
That's a very good point. I'm talking to Brian Koberlein, who is an astrophysicist and a science writer. And we've been talking about this so-called city killer from 2032. We're going to talk in a moment about what's going on in the state of research and what are the big questions that scientists and his colleagues are working on, and what we need to keep working on, or what he thinks we need to keep working on anyway. That's part of the debate. If you've got questions, comments about this, it's connections@wxxi.org if you want to email the program. Connections@wxxi.org. You can call the program toll-free, 844-295-TALK. It's 844-295-8255, 263-WXXI. 263-9994 if you're calling again from Rochester. So there you go. And if you're watching on YouTube, on our WXXI News YouTube channel, you can join the chat there. I see a number of questions. I promise you coming up here, we'll get to as many as we can there. Even, yes, Patrick, about awesome green explosions in your own backyard. So we'll get to as much as we can with Brian. He'll try to diagnose as much as we can. Were you comfortable with the phrase city killer? Was that a fair description for that thing?
I think for the popular press, it gives you an idea of scale.
So in that way, it's functional.
I think it's functional. The idea that, if it hit a populated area, it would do massive damage. It could wipe out a city, but it's not going to cause an extinction, which I think is where in movies we always see, the Bruce Willis level of extinction event where it's going to wipe out the planet.
Yeah.
This wouldn't wipe out the planet.
So on the subject of movies, by the way, have you seen Mickey 17?
I have not yet.
Okay. Have you read the book Mickey 7? Did you read that?
I have not yet.
Oh, wow. A science fiction guy. Come on, Brian. Oh, actually, I don't know if you love science fiction. You love science.
I do, but there's a lot of science fiction out there.
But Ed is local.
I know.
So you got, anyway.
Yeah.
I'm not going to give you a hard time. One of the things that I talked with him on this program last week about was how interesting it is that science fiction gets to ask all of these questions and really think about their application, not just in a I'm going to entertain you in fiction way, but possible application to the human experience or to the experience of life. For example, last week we were talking about how if we end up in a situation where you can upload your consciousness, yes, into a computer, but also into physical bodies that look like you, and you quote unquote die, and then they upload your consciousness, which is what's happening in Mickey 17, the movie that's out now. Is that an authentic form of your life? Is that something that you would desire? Is that something that capitalism would exploit if corporations knew they could convince people for cheap labor you can be immortal? I mean, these are interesting questions that may be coming. And,
Right.
a lot of science writers think probably will be coming. So in that way, did science fiction give us anything of value when Armageddon and Deep Impact came out about trying to stop these things, or was that just pure Hollywood? I mean,
most
that's a
of it's
generation
Hollywood.
old now.
Yeah, I mean, it has to tell a story, but the idea of we should listen to the science, because when we have the data to support that, we know what the consequences are, and also the idea of could we do something to stop it? So in the movies, they blew it up with a nuke. It's the American way, but but the idea that we fragment it or deflect it or something really popularized that idea that, one, we can find these things when they come our way, and two, we might be able to do something about it.
But probably not obliterate them entirely, right? Probably just nudge them off course. That's the idea?
Right. I mean, there are some ideas of obliterating them, fragmenting them so that they would
Which
come
that
down.
would be the American way.
That would be the American way.
Blow that thing up.
And that's, some asteroids are very much loose rubble. So deflecting them may be hard. We may have to fragment them and hope that most of the fragments miss Earth, for example. Ones that are more solid, we can deflect. And so that's something we're still learning is, how do we distinguish between the two? What do we do and how do we handle it? But in terms of like the science fiction books and the movies, the idea of what we're now doing, or at least thinking about, was proposed in science fiction, that this really was a risk and we might be able to do something about it.
Science fiction is useful like that, isn't it?
Yeah, I think so.
I'm surprised Hollywood hasn't brought us more. And maybe there is, and maybe I just haven't seen them. But Deep Impact and Armageddon come out at like the same time. It's got to be 25 years ago or more. And now, what's come out since then?
Don't Look Up.
Yeah,
It's more of a metaphorical movie, but,
yeah,
but it is about an impact.
Okay, all right.
You
That's true. Don't Look Up was the Adam McKay.
Yeah,
He's
and that was one of not listening to the scientists and ignoring the risk.
So what I think happened last month when there was all this talk about this city killer was, for at least a few days, there was this, not like we're all doomed, but it was, wow, 2032 is not that far away.
Right.
And I think it put the public consciousness more in the mindset of, are we ready for something like this? Like, what would we do?
Right.
And so, two questions. If this thing, the one that's a school bus size, if the numbers went the other way, if it was like, we're 70% sure it's going to hit,
Mm-hmm.
all of a sudden it would be a massive worldwide effort to come
Yeah.
up, you would think, to come up with a cooperation.
We would think.
Although these days, who knows? Who knows? I know. You never know. But let's assume that we're not living in, some sort of hellscape, and that we actually would see cooperation to deal with it. How confident are you that in the next 7 years, or probably before 7 years, it would have to be sooner than that, how confident are you that we'd create a solution that could stop a city killer from hitting us?
Moderately confident, I would say. I mean,
Really?
we haven't done it in real time, but we have done the DART mission, for example, where we impacted an asteroid to see could we deflect it, and the answer in that case was yes. In the case of the specific asteroid, because it would fly by Earth and then kind of go in orbit and then come back again, we could get it more when it's farther away. And that's one of the things about having time is if you're a day out, your chance of deflecting it is 0. But if you are at a part of its orbit where it's what they might say, the farthest away, the aphelion, then a small deflection is enough to make a massive change. And so the more time we have, the more we can get it to that kind of critical point in its orbit.
There's a reasonable hope that we could do it. It's not definite.
A reasonable hope, yeah.
Generally speaking, is it about mass or is it about the larger, the more the challenge to stop it?
Well, larger is usually mass. It would be mass, composition, and orbital dynamics.
Maybe mass was. I was told there'd be no science. I was told there would be all science this hour. No, mass was the wrong description. You talk about composition. So when there's different compositions that are a little more fragmented or fragile,
if it's more like loose rubble, that's going to be harder to deflect because.
See, I would have thought the opposite. Why is it harder?
If it's much more solid, you can just ram into it, a single impact, bang, and that will nudge it in the right direction. This is what we did with DART.
Okay.
We didn't try and subtly nudge it. We just took something at high speed, launched it that way, and it bang, just to see how much it would deflect. And we found that it would deflect enough to deflect its orbit significantly. So something that's solid, we can just hit. But if it's rubble, hitting it could fragment it, and that might actually cause a greater risk.
Okay. Well, I mean, maybe there's a group of people sitting in a room right now who could be called upon. I mean, like, does that exist at NASA or elsewhere where
there are experts in the field who think about this all day?
Yeah.
Yes.
That exists.
Yes.
Good. Okay. We'll probably defund that soon. Max in Rochester. Hi, Max. Go ahead.
Good morning. Hi. There's a book called Lucifer's Hammer. Larry Niven, back in the early 70s, I think. A lot more realistic than the movies you were talking about. But in any event, you're calling this asteroid a city killer? That would be if it hit somewhere on a land or near a city. But what if it hits in the middle of the ocean? It would wipe out a whole bunch of other cities.
Okay. Brian?
If it hit in, say, the middle of the Pacific, it would cause some tidal disturbances, but not a huge deal. Usually, if you have to kind of target the release of energy from one spot to another. So, for example, an earthquake in Alaska kind of focuses ocean waves towards Japan. So that would be, a bigger thing. But if you went into the middle of the ocean, say the middle of the Pacific, for example, the waves would go out in all different directions. They wouldn't be focused, and most of the energy would be dispersed.
Depending on the size, though.
Depending on the size. But if you're talking about this size,
the school bus,
the school bus size, it wouldn't be huge. There could be some damage, but it's not going to damage cities on that scale.
Okay. Lucifer's Hammer, do you endorse it?
It was a great book. So I love Niven. So
realistic enough to scare you?
It was kind of the first example of this kind of thing. So yeah, I mean, I guess I was too young to be scared by it, but
okay. Max, anything you want to share before we let you go?
No, but thank you.
Yeah, I mean, listen, science fiction is the way to start thinking about this. And as Brian said, there are people working every day on this. When we come back from this only break, we're going to ask them how quickly they're about to get cut in terms of funding. No, Brian doesn't have all those answers, but we are going to talk to Brian, who's an astrophysicist and a science writer, about the kind of work that is happening that may not be on the everyday American's radar that could get cut here. And what is he concerned about? What does he want us to continue? What are the big questions we're still working on answering? More of that on the other side of this, our only break of the hour. This is Connections. I'm Evan Dawson. Kathy writes to say, hi, Evan and Megan. Fascinating discussion. A number of articles and research from the past couple of years indicate a comet or a meteor exploding in the atmosphere above Earth very likely contributed to the decline and extinction of the megafauna, mammoths, saber-toothed tigers, etc., across the northern hemisphere. And Kathy shares a couple of articles on that. Have you heard about that?
Yeah, there are some theories about that in terms of like either more impacts or a large impact affecting certain environments. I couldn't speak about that specifically, but...
Okay. And let me read from Charlie as well here. Charlie says, Evan, considering today's political environment and what is happening to my retirement account, do you think the scientists could speed this asteroid some way and put me out of my misery? Charlie. He says, seriously, say this asteroid does a really close flyby. Could it possibly wobble Earth off its axis and create a permanent winter or traject Earth closer to the sun and we burn up? So Brian mentioned earlier this hour that typically when you get these flybys, the larger object, I think is what he was saying, which is typically the Earth, will affect the smaller object and maybe, even if we don't collide, affect its course. Charlie's saying, could it go the other way? Could Earth be bumped off our path?
So the short answer is no. But when an asteroid does fly by Earth, it does change our orbit and motion very slightly. Measurable ways, but that just says how well we can measure this.
Okay. Generally, is it about the bigger object will not get bumped off course by the smaller?
Generally, yeah. Yeah, basically, the more mass you have, the more resistance you have to moving.
Okay. Charlie, I hope that answers your question there. And I haven't checked the Dow Jones today. I'm sure it's great. The president said yesterday, don't look at the stock market every day, after he spent the last 40 years of his life saying, it's down 714 points today. That's it? Well, it's early. Don't look at the market every day. Just don't do that. After he told you during the campaign, look at it every day. Okay, let's move on to what the federal government is doing on that subject. And we have seen cuts in a lot of different places. We have seen cuts in the last 2 months literally put people out of work or change funding priorities for research. A lot of it is speculation on what's going to happen. Some of it we know. So let me just start broadly here. What are you hearing and seeing about possible funding cuts, whether it's NASA, other kinds of research, et cetera, and is that a concern for you?
I think what you're hearing is kind of all over the place. I think one of the biggest things is uncertainty. I think short-term consequences I can't predict. It depends on what day it is and which way the wind blows. But in general, if you want to recruit young people to become scientists, you need to have a path for them. So there needs to be some kind of good odds that you're going to land into a career and you'll be able to do something meaningful and contribute, but also you'll be able to feed your family and live an ordinary life. If funding becomes so uncertain that it's just by random whim, these people are very talented. They're intelligent, they're motivated, they're highly trained. Why go into that? Why not pick something else?
We're going to lose scientists?
So we could lose scientists because we don't have a certain stability. A lot of missions are planned on the scale of decades. And that means that a lot of times the people who thought them up retire about the time that it's launched.
Amazing.
And so you have to have the next generation beyond that will step up and learn the skills and do this. A good example is when we went to the moon. It's like we went to the moon, we landed on the moon, something that is unprecedented. And then we cut funding. And so all of those talented young people may have stayed with NASA, may have moved on, but new people didn't come in. And so now when we said, we're going to return to the moon, it's much more difficult because a lot of the skills that we had, we don't have anymore. We couldn't build a Saturn V now. We just don't know how to.
Wow. The mission to Pluto, right? The couple decades, I think?
Yeah.
Is that right? If I'm remembering correctly?
Yeah.
Those
the
amazing
Webb Space Telescope.
Yeah, the amazing images of Pluto we got. We saw the heart. We saw all the beautiful Pluto in color and detail because we got.
Yeah.
And that is something that
it took so long to do that mission that by the time we got it done, Pluto was no longer a planet.
We shouldn't have come here if we were going to decide that this wasn't even a planet.
Yeah.
That's pretty funny. But to your point, though, there were people who probably spent much of their career on that.
Yeah. There are people who first read about the mission and then went to college and then went to get their PhD and then joined the team. So as children, they read about this mission and then became part of the team.
So let me also ask you about how the public thinks about science in general. Before the program began, you used a phrase with me. You said, there's times where people think, well, these are just projects that aren't important.
Right.
Like, well, we can cut this, or do we need to spend this? These are just projects that aren't important. Tell me about the way you would contextualize that.
Well, I think, certainly asking that question is something that we should always ask. We shouldn't just say, because science, let's spend willy-nilly. I mean, that's kind of crazy. But at the same time, we need to put them in the context of what can we do with this. So as an example, when you look at, say, possible asteroids coming to strike Earth, most of them have not been found by projects designed and built to find asteroids. Most of them have been found by sky surveys or satellites that had other missions. And part of that mission was to capture large images of the sky multiple times, day after day, year after year. And that's how you find these. So something like the Gaia mission was really meant to map a portion of our Milky Way. And so it's a space satellite that scans the sky over and over and over again. And so it really wanted to find out, like, what's really the shape of the Milky Way. But it also finds exoplanets. And it finds out, what star systems may have life. And it finds asteroids, because as it's scanning the sky, it will find these asteroids. And when it comes back and scans it again, it will find that it's moved. And so it's finding asteroids in our own solar system, even though that wasn't its primary goal. We have a spacecraft that's supposed to launch today called SphereX that's going to make a full high-resolution infrared map of the entire sky. And it's going to find asteroids. Its mission is to look at galaxies and how galaxies evolve over time. But it will find asteroids.
Just because of the nature of the work it's doing?
Because it's scanning the sky in infrared. And one of the challenges of finding asteroids is that most of what we find is invisible light, which is reflected light. A lot of asteroids are very dark. They're the color of charcoal. And even though they're not hot, they're just warm enough to give off, to radiate infrared light. So when you make a map of the sky in infrared light, you find these glowing rocks that are asteroids.
Is it possible that part of what SphereX will do will detect some of these dangerous near-Earth objects?
Absolutely.
That's possible.
Yeah.
What is the purpose of SphereX?
SphereX, its primary mission is to look at the evolution of galaxies. So it's going to find hundreds of millions of galaxies from nearby all the way to the most distant ones at the very edge of the beginning of galaxies. And because it's looking at infrared, it's going to be looking at gas and dust, star-forming regions, solar system-forming regions. It's going to see how the structure evolved over time, how the chemical composition changed over time.
Who's running the SphereX mission?
It's a NASA project along with lots of other labs.
It's not related to SpaceX. It's SphereX.
It's SphereX, yes.
SpaceX is, well, they didn't have a good week last week.
Yeah.
But
they're a bang-up company, that's for sure.
Well, who knows? Maybe they'll do other cool stuff.
Yeah,
I'm sure they will. They got a lot of money. They do not have a funding issue.
I hope they succeed.
I don't think SpaceX has a funding issue.
No.
Yeah.
And I hope they succeed. I mean, they have launched many satellites.
Yeah. Oh, yeah.
So the SphereX is going to launch on a Falcon. So it's a SpaceX Falcon.
Okay.
Yeah.
Okay. So and that's launching today, SphereX?
It's scheduled to launch this evening, last I checked.
Okay.
It was going to launch earlier this month.
And there's nothing going on with funding that would change that?
Not in that case.
Okay.
I mean, there comes a point where basically the funding is already set. Now, the funding to monitor the data could get shut off. I mean, that's one of the things about like government shutdowns and stuff is you stop tracking data.
Let me also ask you a little bit about what The Hill reported about climate change threatening satellites as they orbit in space. The Hill reports on this study that finds the ongoing surge of greenhouse gas emissions in the near-Earth environment could cause dramatic declines in the number of satellites orbiting the planet by the end of the century. By the year 2100, the satellite carrying capacity of the most popular low-orbit regions could decline by 50 to 66% due to the impacts of emissions. And that's a study published yesterday in Nature Sustainability. Experts determined that carbon dioxide and other greenhouse gases can cause the upper atmosphere to shrink.
Mm-hmm.
This sounds like possible trouble.
Yeah, when the shape of the atmosphere changes, the ability to launch these things changes, and low Earth orbit satellites have drag. They interact with the atmosphere, and so you have to accommodate for that. And if you can't, then that changes. Like, how long are they going to stay up? How much is their orbit going to change? All of this.
Drag. So I'm reading, it says less drag means longer lives for space junk, which
Right.
the researcher said would litter popular orbital regions for decades and raise the risk of collisions.
Right. In this case, because you do a lot of low Earth orbits, what you want to do is you make them small, cheap, and easy. And then when they wear out, they eventually just fall into the atmosphere and burn up. That's the plan. But if they don't fall into the atmosphere and burn up, then they're still there, and they are basically a dead car parked in your parking lot. You can't do anything about it.
Yeah, and space is big. In a moment, we're going to talk about scale with Brian, which is a popular subject, but I still think it's valuable for human beings to think about scale. But just reading about satellites, we've seen a surge in the number of satellites launched in recent years, particularly for delivering, as the Hill says, broadband to internet from space. The New York Times recently had a series about the United States and China doing a lot of, to me, it sounds like high-tech spy work, trying to set up kind of satellite wars, sabotage wars. I don't think we quite know what it is going to be like if we see massive problems with satellites for human civilization.
No, I think one of the things that's a difficulty is, there's a limited amount of space that you can orbit around the Earth. And so a good example of that is the geosynchronous orbit. It's incredibly crowded. And so, those orbits come at a premium. Low Earth orbit is coming at a premium. Everybody wants to do low Earth orbit satellites for communications, for spice, for, all sorts of things. The problem is that different countries want to have their own game. And so you have overlapping satellites that have to avoid each other. And you're going to have impacts, and those impacts are going to make debris. One of the model is there's something called the Kessler effect, where basically debris hits other satellites, which makes more debris, which hits other satellites, which makes more debris, so that you can't have satellites. We can mitigate that to a little bit, but the real danger comes is, what if the United States and China get very aggressive and we start taking out our GPS satellites or our lower satellites?
I mean, there's literally talk about what happens in the future if we use nuclear weapons on satellites.
Exactly.
Yeah.
And there was talk about that way back in the Reagan era with Star Wars. So the thing is, the debris stuff stays up there a lot. And if you start exploding each other's satellites, you now have a debris field, not an orbital field.
So that brings me to the question of scale. So when you think about that much debris, that's a lot of debris that makes it difficult to keep doing what you want to do with satellites. And part of me thinks, well, isn't that what our planet is? Isn't that what Earth is in? We're in this universe with all of this space dust and rocks. And the difference is, the more I read and remind myself about scale, the more it's very different. Whereas in our lower atmosphere, where satellites are, or I'm not even using the right terms. Brian's like, please don't use scientific terms without my approval. But, close to us, we can really flood that with debris. We are in space is so big. Once in a while, I'll see, and the internet's always right, I'll see a picture on the internet where it's like Mercury, next to, if Mercury was a marble, compared to if Earth was a marble, compared to the sun, compared to Betelgeuse, Betelgeuse, whatever you call that.
Whatever you want to call it,
Okay.
That's all fine.
I mean, it's incredible how much bigger the sun is than the Earth, and how much bigger Beetle thing is than the sun. And I want you to talk a little bit for a moment, like when we see headlines about this black hole that's expanding that I was reading about last week, and I'm like, oh my gosh, it's expanding so quickly. I mean, our time's got to be numbered here. It is numbered in the billions of years. That's how big the universe is.
Yes. Yeah.
Yeah. So how do we sort of conceptualize scale that way?
I think I think it's better to look at the connections than it is to look at scale.
What do you mean?
Well, scale starts to become just a numbers game. So you say, 1 billion years, 1 trillion stars. What does that number really mean? It's hard to visualize what
A trillion is.
Yeah, what a trillion is.
Yeah.
What's a billion?
Yeah.
You know, billions and billions of stars.
Yeah.
Like, what does it all mean? And when we get over kind of practical, everyday numbers, it becomes increasingly difficult to visualize at scale. And you can do the scale of a marble. You know, the one I like for the size of the Milky Way is that if you take the entire history of human civilization, and I mean be liberal and say 12,000 years, for example. Look at how far light can travel across the Milky Way in 12,000 years. And it can't even traverse from one arm to the next. It's one patch within the Milky Way. You know, so if the Milky Way were the size of an LP, it would be, you know, basically the size of the 12,000 path of light would be basically a disc the size of the, you know, the 45 records.
The
I'm
old
really
45.
dating myself,
There you
but the
go.
old 45.
Yeah.
So that's the area within an LP that light has traveled in the lifetime of human civilization.
We have no concept of this.
You know, it
is-
takes 100,000 years for light to travel from one side of the galaxy to the other.
Which gives me comfort that we're never going to be hit by. Not never. The dinosaurs were. We're unlikely to be hit by one of these massive objects, but that to me says there just must be a lot out there.
There is a lot out there, but again, coming back to the connections idea, we have through the entire history of the human species, we've had a few impacts, but nothing that really impacted humanity. We've just been lucky that way. We've had volcanic activity that's impacted humanity more, but we are now, after all of the history of human civilization, we are at the point where we are realistically talking about finding and moving rocks, so that the risk doesn't remain tiny. It goes to zero. And within a couple of centuries, we may have that. If we step up to the challenge, we could make the risk of an impact on Earth zero. We've never been able to do that.
Remarkable. Elizabeth writes, Evan, I'm tuning in late, but have you talked about the TV show Paradise and what exactly happened to the Earth on that show? I don't know Paradise. Do you?
Paradise is one of the two apocalyptic TV shows. There's Paradise and Silo.
Are you watching Paradise?
I haven't watched Paradise yet. I've been watching
So I don't know if
Silo.
Elizabeth is asking for a spoiler here, so I want to be careful. Maybe producer Megan Mack can figure out what happened to Earth on Paradise. Doesn't sound like it was good anyway.
It basically, they're both bunker stories.
Bunker stories.
So they're kind of underground in a bunker for the rest of civilization. Paradise is basically like a 50s utopia underground mall, whereas Silo is like government housing.
Elizabeth's interest in Paradise, producer Megan Mack says a super volcano triggered a tsunami that covered much of the Earth.
Yeah. Yellowstone.
Sounds bad. Okay. I was a little fuzzy on this good bad thing this hour. Important safety note. Thanks, Egon. Okay. There. I can quote Ghostbusters there. I shouldn't have given it away. I should have just left that as an Easter egg for people. Okay. Lastly, as we get ready to wrap up here, Dallas wants to know, ask about the Southern Anomalous Area. That is a crazy thing. What is the Southern Anomalous Area? What's he talking about?
Is it? I guess is it the zone of avoidance? Is what he's talking about.
I don't know.
So
Dallas, you have to clarify.
So the zone of avoidance, for people who wouldn't know, is in the center of our Milky Way. And you can really see it in the southern hemisphere. If you look towards the center of the Milky Way, you don't see a whole cluster of stars. What you see is just dark clouds. And so what that means is, particularly in optical light, we can't see anything in that direction. And the fun part is that somewhere behind the zone of avoidance is a large supercluster of galaxies that's pulling the Milky Way towards that. So there's this great attractor somewhere past the zone of avoidance that's pulling the Milky Way towards other galaxies.
Sounds like trouble for us in the future, like our ancestors.
Yeah. You know, like
a billion years ago.
billions of years. Yeah.
Yeah. I'm sure we'll still be here in a billion years. Okay, last minute or so. What's the next big thing that you're watching now? Is it federal funding? Is it making sure we can keep doing what we're doing? Is there some really interesting question that scientists are working on that you're keen on them giving you some answers to in the next year?
Yeah, I think what's going to be really transformative, at least in the long term, is going to be these large data observatories. So we are now at a point where we are gathering so much data that it's really the analysis of the data that's more of a challenge than gathering it.
Is that a place for AI?
It could be a place for AI, but one of the things that's interesting is that data starts getting open to the public. So the old school way of doing astronomy is I write a grant and I get telescope time and I gather data, and that data is my data. And I get an exclusive period to analyze the data before anybody else does because I wrote the grant. And when you get something like the Vera Rubin Observatory, for example, is going to capture wide areas of the sky, clean it up a little bit, and then release it to the public, which means anyone with a computer or AI or anything can look for things in the data.
Pretty cool.
Pretty cool.
That's a good thing.
That's a good thing.
All right, well, that's exciting. That's an optimistic note to end on of what's been, I think, a pretty optimistic hour. I don't know. I've been told when my voice goes up like that, it betrays I don't really believe what I'm saying. It was pretty optimistic.
It's fine.
It's fine. Everything's exactly. It's good. Everything's good. Everything's great. This is really fun. Thank you for coming back here.
Thank you very much.
Keep us informed, as always. Brian is one of the best. He is an astrophysicist and science writer, Dr. Brian Koberlein. And from all of us at Connections, thank you for listening. Watch the skies, stay safe, and we're back with you tomorrow on member-supported public media.
This program is a production of WXXI Public Radio. The views expressed do not necessarily represent those of this station, its staff, management, or underwriters. The broadcast is meant for the private use of our audience. Any rebroadcast or use in another medium without expressed written consent of WXXI is strictly prohibited. Connections with Evan Dawson is available as a podcast. Just click on the Connections link at WXXInews.org.